Alright, let's look at the homework 2.5, problem number 8. Alright, so we have this curve, y equals absolute value of x over square root of 5 minus x squared. And we want to find an equation of the tangent line to the curve at point 2, 2. Alright, so let's do that. Alright, so we need to take the derivative, but notice that the x value is 2, which means that the absolute value of x is going to be just x because it's already positive. So we're going to just take the derivative, pretending that this is going to be y equals x over square root of 5 minus x squared. Right, so let's take the derivative. So y prime is going to be, alright, so we have to square the bottom, so that's going to be 5 minus x squared, right? And the derivative of the top is 1 times this bottom guy, square root of 5 minus x squared, minus, so you have x, then multiply by derivative of square root of 5 minus x squared. Right, so square root of 5 minus x squared, and I don't like square root, so I'm going to write it as quantity 5 minus x squared to the 1/2 power. Right, then if you take the derivative of this guy, you will get put 1/2 in front, keep the same inside function, right? Subtract 1 from the power, so it's negative 1/2. Multiply by derivative of inside function, so it's a negative 2x, right? Then we can cancel 2 on the bottom and 2 on top, and you will get negative x over, right? So it's a negative power, so you can put 5 minus x squared on the bottom, and 1/2 power, so it's a square root, right? So that goes right here, right? So you have a negative x square root of 5 minus x squared, right? I don't like to have a fraction inside a fraction, so I'm going to actually go ahead and multiply the top and bottom by square root of 5 minus x squared, right? So what you get is this. Right, so you're going to get, so this is 5 minus x squared to the first power. So this is 1/2 power. You can combine them. We get 5 minus x squared to 1 plus 1/2, so 3/2 power. And on top, you're going to get, so square root of 5 minus x squared with itself is going to be 5 minus x squared. Right, then square root of 5 minus x squared cancel out. So you're going to get the positive x squared, right? So you can see that negative x squared and the positive x squared cancel out. You're going to get the 5 over, right, quantity 5 minus x squared to the 3/2 power, right? Then if you want to find the slope, all you really have to do is m is equal to evaluate y prime at x equals 2. Right, so if you plug it in, you have 5 over, right, 5 minus 2 squared is 1, so 1 to the any power is going to be 1, so it's 5 is the slope, right? So equation of the tangent line is going to be, so therefore, y minus y1, so this is our x1 comma y1, so it's 2, is equal to, slope is 5, and times quantity x minus 2, because x1 is 2. Alright, so let's type it in. Alright, so equation is y minus 2 is equal to 5 quantity x minus 2. Alright, so we have that. Then we can look for an example. So slope is going to be 5. You can see that this is absolute value, so it's never negative. So it's never go below the x-axis. This is not going to be it. And this is not going to be it. So it's going to be either this one or that one, right? Then if you look at the derivative, you go back, right? So if you look at the derivative, when x equals 0, for example, the derivative is going to be positive, so it's going to have a positive slope. Alright, so this one, you can see that here we have a positive slope on this side, and but here, this is the slope is 0. So I think this is going to be the correct picture. Alright, so let's submit for testing. Alright, it came back. Looks like we got the part A correctly, and the graph was correct as well. Alright, that's it. I hope that this was clear.